of pre-cal on the ACT. So our goal is today we're going to review a lot of pre-cal ACT questions. On Wednesday, we'll do a lot of geometry ACT questions. And then the third day, we'll focus on Algebra 1 and Algebra 2 ACT questions. Okay? So that being said, okay, even if you're a senior and you do not care about this, you're going to just follow along and be a good sport. And then when we're done, you can just be a happy little senior with not a care in the world. Okay? All right. So take a look at the first one. Oh, and y'all, you do have to have a calculator. Did you grab one? Did I tell you that? If not, will you get one? Okay. Not you, silly guy. Want to follow along? Wow, such motivation. All right. So take a look at the first one. Yes. It's next week. So we have Monday, Wednesday, Friday. It's Tuesday then, because it's the next day after that. All right. So if you can't read it, it says right here, okay, y equals okay, negative cosine x plus 5. Okay, so first question, what does the plus 5 do to the cosine graph? Which way does it shift it? Up, and then what does the negative do? Flip it, yeah? So your normal cosine graph, if you don't remember, it looks like this. Oh, you can't see that. Okay, normal cosine graph looks like this. So all that you have to do is think about what changes is the plus 5 and the minus going to have on the graph. Well, we know the plus 5 is going to shift it up, which means it pretty much has to be one of these two. And then which one of those shows the cosine wave starting at the bottom instead of the top? Okay, notice your B here goes like that. Okay, so it would have to be answer choice B. All right, let's take a look at the next one. Actually, probably the next one you can do it here. So I'm going to skip it. Go down to your bottom couple. Let's say we're going to do this one. Okay, what number affects the period for a trig function? You have a 5 in the front, you have a 4 and a plus 60. Which number changes the period? A 4. And if they put a times 4, how do I find the new period? Okay, the new period is going to be divided by 4 on what original number? 360. So what is 360 divided by 4? 90. Okay. Now, this other one says, where would you end up in standard position if you were at 17 pi 4? So this one's a little bit tricky, but you can do it. Okay, I want you to draw yourself a unit circle. How many pi's does it take to go all the way around the circle? 2 pi's. So I see that this is a 17 pi over 4. So I'm going to start off by saying, okay, well then if I go across the top, that would be 4 pi over 4. Now think about how many full pi's is that if it's 4 divided by 4? 1. This is 1 full pi. If I go around again, I do another 4. How many would I be at? 8 pi 4. Okay, now remember, I'm trying to get to 17. So I went 4 across the top, 4 across the bottom. Now we're going to have to go 4 across the top again. If I do 8 plus 4 more, what's this? 12. Okay, 12. And then if I go 4 more across the bottom, what am I going to be at? 16 pi fourths. And then I want to be at how many? 17 would just be a little bit more, not all the way across the top, right? 17 would put me right here in which quadrant? 17 pi fourths would be somewhere around here in quadrant 1. Okay, so I would just think about it. If the top's 1 whole pi, that'd be 4 fourths, then 8, 12, 16, 17 would be just tip it a little bit more into quadrant 1. Okay, and then remember that the word for that is coterminal angles. Okay, where they end up basically in the exact same spot. Okay, go ahead and turn the page. For most of the trigs, you're just doing SOHCAHTOA. So let me hit maybe 2 of these. Let's start with this one. Okay, I want tan of R. So put your theta in the R corner. So I can barely see it, but my R is up here at the top. And then if I want tan, is that SOHCA or TOA? TOA. So tan R is going to be O over A. Now remember, O stands for opposite, A stands for adjacent, and my theta is up here. Which side, little t, little s, or little r, is opposite from my theta? Little r. And then which side is my adjacent to my theta? T. Very good. So it'd be R over T, which is answer choice G. Okay. The side that we didn't label, what is this one called? Do you remember?
That's the hypotenuse.
Hypotenuse. Very good. Okay, so this is the hypotenuse. This is the opposite. This is the adjacent. And remember, you can tell the difference from the opposite and the adjacent because the adjacent's got to touch the theta, right? All right, we're just going to do one more from this. Let's do the one at the very bottom of the page. Okay, so you can see most of these ACT questions should not take 100 years. Okay. We know that sine, weird little a, is 12 over 13. Cosine is 5 over 13. Draw me a little triangle. Pick a corner to put the funny a in. Okay, so let's put it here. Okay, technically that's an alpha, but it really doesn't matter. It's fine. Okay, so instead of using a theta, they use an alpha. But it doesn't matter. If this is where my angle is, where will I place the 12 and the 13 if it's a sine? You could, that's fine. Say it again.
Put the 12 opposite.
So the 12 is the opposite.
13. Right.
The 13 is the hypotenuse. And then on my cosine, I know my adjacent has to be what number? 5 over 13. Okay. And then from there, they're asking me for tan. Well, then which sides do I want off this triangle? SOHCAHTOA. 12 over 5. And then what Nate pointed out, maybe drawing the pictures a little extra, because really you can kind of see the 12 is an O, the 5 is an A. So that's a good point. You wouldn't necessarily have to draw the picture for that. All right, go ahead and turn the page, please. All right, let's do just a couple triangles and then we'll take a little break here. So will you take a look at angle of elevation, and we'll do the second question. Okay, this one right here. So it says we have an 8-foot ladder leaning against a wall that makes a 60-degree angle with the floor. So we have wall, ladder, floor. Okay, it says what is the height of the ladder? So I'm going to put my H here. Okay, that's going to be my unknown. And then they tell me how long is the ladder? 8 feet. And I know that I have a 60-degree angle with the floor. Okay, now if this is the right triangle, I automatically also know, okay, that this is a 90-degree angle. So let me remind you, you learned a law of sines and a law of cosines. Okay, so if I was trying to do the law of sines, I would need partners that are across from each other. Do I have that? And when I say partners, I'm referring to an angle and a side that are opposite each other. Yes, I have my 90 here, and then what's across from it?
Eight.
My 8. So it's gonna be sine 90 over 8 equals, and then remember, these are my other partners, right? So it'd be sine 60 over h. Sine 60 over h. Now, it's asking me to find the height, so let's cross multiply. Okay, in your calculator, and actually, looking at the answers, do you see they didn't actually times it out? So let's not type it into the calculator. So if I do sine 90 times h, I'm going to get sine 90h. And then the other diagonal, what I would normally put in the calculator would be 8 times sine 60, but I'm just going to kind of leave it like that. Okay, then normally your last step, if this is multiplied with h, how would I get rid of it? You would divide it, but sine 90 is a special number that, do you remember when you divide by sine 90, it doesn't change the answer? Okay, so I'm going to divide by my sine 90, but then remember that when you do that, the sine 90 doesn't change anything. So your answer would stay 8 sine 60. Okay. Which would be answer F. Yes, ma'am.
So a lot of expressions like just giving us the equation for like the answer. Is that how it's gonna be?
It kind of depends. So sometimes the ACT will have the numeric answer, and then sometimes it'll be more of like a procedure type question. Okay, but let me just remind you, why does dividing by sine 90 not matter? Because it's equal to 1. Okay, now if you type this into your calculator and you don't get a 1, it's because your calculator's not in degree mode. So if you want to check that, type in sine 90. If it doesn't give you 1, okay, your answers on the next few questions will count. Okay. All right, we're gonna do maybe 2 more and then take a break. So go ahead and turn the page for me, please. Let's do law of sines. First question. Okay, so it says, what is the length of JK? So JK would be the side connecting big J to little k. Now, remember, bigs and littles are supposed to be across from each other. So if I want to label this side, would I call it little j, little h, or little k? What would I call this pink side? Little h, very good. And then remember, in order for me to do law of sines, I have to already have partners. Okay, so looking at the side 10, do I have its partner across from it? I have the 40. So those are partners, so let's set it up. Sine 40 over 10 equals. Okay, because they're partners, they're across from each other. And then if I'm trying to find little h, I have to already know big H, do I? Do I have big H right now? No, but remember, what do all 3 of them have to add up to? 180. So if I need to know how big this one is, in your calculator, do 180, take away the 2 angles that you have, and then whatever's left over has to go in that 3rd corner. So I'm going to minus the 75 and the 40. That gives me 65 degrees left in that spot. So I'll do sine 65 over h. Okay, but remember, big H and little h have to go together. Big K and 10 would be little k have to go together. Yes, ma'am. Did I type it in wrong? 180 minus 75 minus 40? Yeah. Oh, okay. No worries. So then from there, sine 40 times h is going to be sine 40 times h. But then on this one, do you see how my answers are real decimals? Then I'm going to actually do the multiplication in the calculator. So in your calculator, do 10 times the sine of 65. We're going to multiply this diagonal. So 10 times the sine of 65. I got 9.063. And then what's my next step to get h by itself if it's multiplied by sine 40? Very good. Go ahead and do that in your calculator. Very good. So this divided by sine 40. Okay, we got 14.099, which is closest to 14.1. Okay, now, if you look at the next question, I'm not going to do it. But do you see how they just have it set up? So that would be an example where instead of you actually figuring out 10 times sine 65, you could just kind of leave it, put it over sine 40, and then look for the answer. Okay, so the ACT will be a mix of both. All right, go ahead and turn the page to a law of cosines. And let's do the second one. Now, first question, why can I not use law of sines? What do I not have that I need for law of sines? You got to have a side and an angle that are across from each other where you know both. So for this triangle, I see that I do have two sides, but I don't have either one of their partners. And then I have the angle in the middle. So this is a side angle side, which means that you're going to have to use the law of cosines. Okay? And if you look right above this, the law of cosines is right here. Okay, so I'm just going to be using that formula when I type it in down here. So I'm going to call this capital C, which means this is little c. And then I'm going to call this, let's do this one will be big A. That makes this little a. Big B makes this little b. Okay, but remember, the main thing that you want to do here is just make sure that what you're finding is your little letter across. So I want to find the distance from Dearborn to Fergus. That means I'm using the equation that starts with c squared. And then notice it's written right there on your paper. Okay, go ahead and plug in your numbers. So it'd be c squared equals, my little a is an 80. My little b is a 120. Minus 280, 120. And then remember that cosine capital C is referring to this angle, which is a 127. Now, once you plug those numbers in, do you notice that your C is already on its own side? That means you can type this whole thing into the calculator together. You don't have to do like the 1, 2, 3 like we did on those one questions. So go ahead and type this whole thing into the calculator. Okay, and then I got a really big number and there's no answer choice that says that. What do I still need to do? Square root your answer. Very good. Okay, so remember, you're not done until you have C. So C squared is not quite finished. So then my C comes out to be 179.874. That's going to be closest to 180. Okay. All right, then the top and the bottom questions on this page are the slightly harder law of cosines. So why don't we do the bottom one and then hopefully you can do the top one. Last question for now. Okay, so it says the sides of a triangle are 5, 12, and 13. Draw yourself a triangle. So my short side is a 5, 12, 13. Okay, it says, what is the angle between the two shortest sides? So where should I put my angle that I'm trying to find between? Which two numbers? 5 and 12. So let's call it big C. That makes this little c. And then out of the other two, it doesn't really matter which one's A and B. I'm gonna let this one be A and this one be B. Okay, we're using this exact same formula right here, so plug your numbers in. So it's gonna be C squared equals, but I know C. What's little c? 13 squared equals. And then it's A squared plus B squared. So 5 squared plus 12 squared. Minus 2AB is 2, 5, 12. And then cosine big C, which I don't know. Okay, remember that when you're looking for this guy, notice it's got all this crap on the same side. You can't just type it all in at once. So remember, this is where you would say it's easy as 1, 2, 3. So do the 13 squared by itself, the 5 squared and the 12 squared together, and then the 2, 5, 12 together. So go ahead and do that for me now. So my 13 squared came out to a 169. Ooh, 5 squared and 12 squared came out to 169 again. Minus 120 cosine C. Okay, from here, I'm trying to get this guy alone. What do I do with that to get rid of it across to the other side? Minus it. What is 169 minus 169 again? 0. Okay, you're not done. You end up with this. Kind of weird, but just go with it. What would pretend this is a number other than 0. What would your next step be to get rid of that? Divide it across to the other side. So I have the cosine of C is 0 over negative 120. Okay, then how do I get rid of the COS in the front so that I can know how big angle C is? Do you remember? Inverse or second cosine on the calculator. Okay, so go ahead and do that. So it'll be COS minus 1 on both sides. And then I want 0 over negative 120. Okay, and it comes out to how many degrees? 90. Okay. All right. So I'm going to give you a little time to work. We'll do a couple more examples in a little bit, but just focus on the types of things we just covered. Okay, don't work ahead in the packet unless you're just feeling really motivated. Okay? Because a lot of the other stuff is more geometry-ish. Oh, wow, she did this all in one packet. Y'all, if you're thinking, oh no, this is so long, this is all 3 days in one. You will not get another packet. This is the only packet that I thought we were doing this. Okay.
Anything but the students and all that.
All right, y'all, just to finish up our last examples, just because I'm impatient and I want to end my little recording. Okay, will you go to this question right here, the secant cotan?
District people came in, and he was like super long.
All right, here we go. Secant. Secant is which one flipped? Now this you will not get on the ACT. You do have to remember who the partners are. Secant is cosine flip. Now cosine is A over H, yeah? So what will secant be?
H over A.
Okay, put H over A times. And then what is cotan? Which one flipped? Tan flip. So if tan is TOA, what will cotan be? A over O. And then what happens if I have an A on top and an A on bottom? What can happen to those? Cancel them out, and I'm left with H over O. Now, I want you to think about, is H over O one of the originals, or is it a flip? It's a flip of who? Sine is usually O over H. Then H over O is going to be sine flipped. Which choice is correct? Good job. Okay, so if you can remember SOHCAHTOA and the 3 flips, okay, that problem's not too bad. Okay, go ahead and turn to the next page where we left off.
All 3 of them put people together, right?
Say that again.
Like, it's never gonna be A or B if you get a question.
Correct. Well, unless if you had H over A times A over H, and then everything crosses out, then it could be 1. But it could never be 0. You're right. Yes, sir.
Between H over, like where you wrote A over O.
It's a multiply. Because it says to multiply them here. Right there. Oh, yeah. All right, so go ahead and turn the page. Okay, we left off on area. Okay, so do we remember the area formula for a triangle? Okay, it is 1/2 base times height. Now, you'll notice that on this triangle, not only did they not give you the base, but they also didn't give you the height. Okay, which is a little bit annoying, but we can find them using law of sines or cosines. Now, first question, can I start off with law of sines which partners do I have already? The 90 and the 12. So let's go ahead and find sine 90 over 12 equals, and then sine 50 over the side across from the 50. In the area formula, would I want to use the base or the height? Whose partner would 50 be? The height. Very good. So I'm going to just go ahead and call it H for height. Okay, then go ahead and solve that. So sine 90 times H is sine 90H. And then 12 times sine 50. What do we get for that? Okay, 9.193. And then what's my next step to divide by what? Sine 90, and does that change it? Remember, whenever you divide by sine 90, it's just going to keep that number the same. So I'm going to put that this side is 9.193. That's the height. Okay, what's the other side that I need to find area? The base. And if I need the base, I also need the angle across from it. Is that a problem? Because if I have these two, how can I know that top angle? Minus it from 180. So I'll do 180 minus 90 minus 50. How much is left for that top corner? 40. And then from there, I'd set it up basically the same way. It'd be sine 90 over 12 equals sine 40 over the base. And then remember that when you times these out, the sine 90 doesn't even matter. It doesn't change anything. So basically, when you times these two numbers together, you'll know how long the base is, and then you can find the area from there. So we're going to do 12 times sine 40. And I got 7.713. And then divide by sine 90, and that number stays the same. And then how do I find area? My formula is right here. Remember, it's 1/2 base times height. So my base is 7.713. And my height is 9.193. Okay, just like that. So 1/2 base times height. Answer is 35.4, which is answer. Now, For this second question, I'm not gonna do the area for you, but I'm gonna set up the picture and then you can just count the base and the height. So, I'm gonna make a triangle with 3 lines. The first one is gonna be 3/5 x minus 3. Okay, we've graphed a little bit, but it's been a while. So remember, it's y equals mx plus b. B stands for my y-intercept. Where am I gonna start on the y-axis for the b? What number? -3. So I'm gonna go down 1, 2, 3, put a dot. Then m is my slope or my rise over run. So I'm gonna rise 3, run 5. Rise 3, run 5. So go up 1, 2, 3, 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, 4, 5. And then that's good enough. Okay, there's my pink line. Okay, the next equation I'm given is -2/5 x plus 2. So where am I going to start for that equation? What's my plus b number this time? 2, right here. And then my slope this time, do you see that it's a -2/5? So I'm going to go down 2/5, down 2/5. So 1, 2, 1, 2, 3, 4, 5. 1, 2, 1, 2, 3, 4, 5. 1, 2, 1, 2, 3, 4, 5. Okay, and then the third line is x equals 0. Okay, that would just be this line right here. Okay, if you remember, we talked about Hoyvux. Okay, that would be a vertical line through x equals 0, and then you can now see your little triangle. So write down its area equals 1/2 base times height. And then here's going to be the easiest way for you to do this. Okay, you see how your triangle, like if I make this the base, then I can't really count how tall it is. So I want you to just make your life easier and turn your paper sideways. How long is the base? How many boxes? How tall is it? How many boxes? 5. See how it's 5 across? 1, 2, 3, 4, 5. And then 5 tall. 1, 2, 3, 4, 5. So then you can do 1/2 5 times 5. Okay. So you can change your triangle to be facing whatever way you want to make it easiest on you. So it'd be 1/2 5 times 5. And then you can use your calculator to match the decimal there. Okay. All right. Then let's just do, I think you can probably do the next one. We'll do the very bottom one. It says AB is parallel to DC. You should have done parallel lines until you wanted to throw up in geometry. Okay, parallel lines have like a million different rules, okay, on how they relate to each other. Yes? I think it should have been 12.5. Because 5 times 5 is 25. And then divided by 2, yeah, it should be 12.5. Okay. So, I don't know if you remember, we're looking for angle C. So put your little question mark in angle C. Do you remember the rule about these two angles, what they have to add up to if they have a line that cuts through them? 180. So if this is 85, just minus it from 180 and that would give you whatever's left over here. So these two angles, they're called alternate interior angles. Okay, these have to add up to 180. So if you do 180 minus, then you'll know how big angle C is. Now, if I wanted this one, what would I minus from 180? Its partner would be the 45. So alternate interior angles should add up to, or wait, this is actually same side interior. It doesn't matter. They add up. I think okay. So then it would be 95. Okay. All right. Good job. So then this is your stopping point for today. Don't do any questions past there. Please don't lose your packet. It's a million pages long and we'll kill all the trees.